Say again?
You meeting is now streaming live on YouTube. I didn't know we could do that.
Yeah, so I think we're good. And hi, I'm Stephen Guerin with Redfish and Sim Table here in Santa Fe. 2 miles down the road is also Owen Densmore. Owen, you want to introduce yourself?
Hi. I'm Owen Densmore. I work with Steve on all things complex. I had a long career in Silicon Valley, and we're here to tell you our story.
Yep. And I want to take this opportunity. We have the Super Bowl coming up this Sunday. Today is Tuesday, and it's 40 years from a previous Super Bowl when the Macintosh was announced on the famous 1984 commercial. And then a couple days later, there was the public unveiling and some interviews with the team. And Owen was one of the critical members on the Macintosh team. So I wanted to take this opportunity to one celebrate that moment 40 years ago, which in
Mm.
for reasons will become clear later, I think it really changed the face of computing, and especially the component that Owen worked on, which was what you see, what you get printing. The fact that what's on the screen, what the Macintosh was doing with quick draw and graphics, first of all, was revolutionary. But to get that out to the printer and the program running on the printer to interpret it, I think changed an industry, and certainly the pre-press industry and everyone that prints to laser pointer printers and graphics on their printers. I think we have Owen to thank for that. So we're going to do a little bit of interview, but first we're just going to go down memory lane and look at the 1984 commercial and a certain segment of that release at the Boston Computer Society a couple days later. I'm going to go ahead and share my screen here. And here is the 1984 commercial.
Today we celebrate the first glorious anniversary of the Information Purification Directives. We have created, for the first time in all history, a garden of pure ideology, where each worker may bloom, secure from the pests of being contradictory thoughts. Our unification of thoughts is more powerful a weapon than any fleet or army on earth. We are one people, with one will, one resolve, one cause. Our enemies shall talk themselves to death, and we will bury them with their own confusion. We shall prevail.
On January 24th, Apple Computer will introduce Macintosh. And you'll see why 1984 won't be like 1984.
Right. That was a nice Ridley Scott directed commercial, and folks can pull that up with their phones or just search on Macintosh 1984 commercial. It'll come right up. So what I'd like to show now is this video here, which is in the Computer History Museum, and um, QR code here. And basically, January 24th was released to the shareholders out in Palo Alto, and then the whole team redid the demo with Steve Jobs in the beginning here, giving a classic Steve Jobs demo. We're not going to go through all that, but he's going to talk about why they can't live in an IBM world and all the beautiful things with graphics. And then you're going to see Bill Atkinson talking about Quick Draw and what they're doing with the printer. Andy Hertzfeld here talking about hardware. And then here's a certain point where now there's a question from the audience member about letter quality printing and daisy wheels. And it was a big revolution not to go that direction and go for being able to print a graphic or a raster, and knowing that the resolution of printers will be such that you don't need to have a daisy wheel printer. And for the youngins, back in the day, there used to be a wheel with fonts on them, and they would impact print on the printer, just like a typewriter, right? But it was really hard to do graphics with it, and I was when this was going on, I was a 13-year-old sitting with a bitmap printer on my TRS-80, and also doing a photo typesetting in my high school with shout out to my journalism teacher, Chuck Knowles. We had a photo typesetter, which you're going to hear in this question. So with no other further ado, I'm going to play this bit here.
Next. Yeah, in the back there.
You have an intermediate letter quality printer, which we talk about the laser printer and the dot matrix.
The question is, do we have an intermediate letter quality printer? The answer to that is yes and no. I'll handle the no first. No, we don't have one. Because we don't believe in them. We believe in letter quality output, but we believe in getting that through much higher resolution dot printing, such as a laser printer. The Macintosh hardware supports letter quality printing, and some people like Microsoft are going to probably support daisy wheel printers. The problem is, how do you print the fish with a daisy wheel printer? And how do you print Old English with the daisy wheel printer? Let me ask Owen Densmore to jump in. Since Owen wrote all the printing for Macintosh and Lisa, he's like a printing guru.
I'm not too sure what the question is, other than are we going to do something like that? The most important thing from my standpoint, and the largest challenge I faced when I worked on the Macintosh, was really to design the printing interface so it was a miniature application running inside the host program. It's fully configurable. It's rather easy conceptually anyway. You stay up a lot of nights working it out, as my family can attest. But it's a very configurable design. The idea being that if a given application sorely needs a daisy wheel printer to make the revolution happen, it will happen. Unfortunately, it's not very much fun, and Bill gets to have all this great time, you see, with this, with his graphics program. And I don't want to be left out, so I want to go after color. I want to go after higher resolution. I want to go after typesetters. I think that there's a big need for typesetting applications in the industry, and I think we're going to do that. I think that really is going to be more interesting.
One final note. If you look at the output that you get off a $500 ImageWriter printer, it's pretty amazing. And we can't stand up here and say it's letter quality printer, letter quality output that you might want to send out of a legal office. But with the exception of those kind of very high-end applications, you'd be surprised at how good it is. And the beauty of the fonts, in many cases, makes up for the slight lack of resolution. You ought to take a look at it. It's pretty good. Anything else?
Right. Well, stop my share here for a second. So what are your comments seeing that again, Owen?
Boy, it's a blast from the from the past. It's interesting that even that long ago, we were toying around with just what you could do. A lot of people didn't know that the printing inside the soon-to-be product, the laser writer, we actually downloaded the code into the printer because there wasn't enough room on the Mac to handle it. And so we just literally, Bill Atkinson, Steve Capps, and I came up with a way to basically take the quick draw output, the SPI. The API is what faces the developer. The SPI is what faces the machine. And
that's a systems programming interface?
System programming interface.
And what is that? So application programming interface, people kind of know is, I want to call this program and call its functions. What's an SPI?
Well, the idea behind an SPI is that you want to be able to make your program as configurable and deployable as possible. And the way you do that is, instead of saying, okay, for every piece of hardware, I'll just go build a new driver, basically. What you do is you build something that outputs a known format. And so what we basically did is took Bill Atkinson's Quick Draw and build a version of it, if you will, that was designed to go toward hardware. And so we were able to get it to work on the laser writer by having that piece of code literally be sent to the printer, and then the printer would convert that into the what it needed. In that particular case, PostScript.
I see.
Um,
Yeah, and earlier in the demo, Bill Atkinson's showing off Mac Paint, right, which was
right.
showing off the quick draw, um, which were ways of handling vector shapes and erasing. That blew people away. If people watch that, here's the vectors and the fills, and then I can erase this. So it's kind of like a raster, kind of like a vector. And I remember fat bits was a big deal. You could zoom in and out. And he also was drawing a fish and manipulating it, making many copies. So, and I think that was the point of Steve Jobs' nice quote. Well, how do you print the fish? You can't do that with a laser or with a letter printer or a daisy wheel. So back up a little bit, Owen, too. And what was your journey to that stage there? Where were you? Well, first of all, where did you grow up? What did your parents do? And then how'd you kind of start on this vector into graphics?
Well, I was a kid in Orlando, Florida. Uh, went on. I didn't particularly like it there, so my vector was monotonically increasing. I went to Georgia Tech, and then I got interested in the Peace Corps. I when I
What
got
at
to
Georgia Tech? What did you study?
physics,
Okay.
and I was so burnt out when when I got through with it, I didn't want to see the inside of a school again. So I went to Ghana, West Africa, which is really quite an experience. Um, Teaching kids. Uh, and then when I came back home, it a really funny thing happened. I decided I did want to go back to school, and I took the SATs, I guess they're called, in Ghana. And the funny thing, I got this letter in the mail saying you're accepted. And I said, what? And it turns out that uh, I did well on the exam, and a school found out about it. This was Syracuse University, and the physics department head got me a fellowship, NSF fellowship, just on that. And so I come back and I've got a lovely place to continue learning.
And
And
this is
then
what years? This is kind of
let me
what
see, it
year?
would be 67, 68. Um,
So Vietnam's kind of in full
yeah,
blast at the time. Yeah.
and so I went ahead and got the master's degree and took the quals and that for the PhD. But I was, I guess, enough anti-war at that point in the school was we couldn't convince them to take some steps at least to make a noise about the war. And so I you could once you passed your quals get a master's without going through any other work. So I did that and went out to California and had fun at Berkeley Computer Corporation, BCC. It was rather famous at the time for what they did. Um, and then
What were you working on there, Owen?
I was mainly working on hardware, figuring out ways to debug it and to find out and do quality control and stuff like that.
Mhm.
I'd been busted before that, which is a long story about politics. But and so I had to go back to New York to go through the trial, and then we decided to get my lawyer decided you really ought to have a good job in order to go through this uh, trial because it'll show you're a good citizen and all that. So we ended up in Vermont, um, again teaching. Had a good time there, although there's a lot of stories about them. But nonetheless, when that was done, we decided to live in Rochester. We lived there for 8 years, working with Xerox, and then went into Silicon Valley, and where I worked with the Mac team, and then for Sun Microsystems.
So so there's famous stories of some of the Apple team touring Xerox, the Palo Alto Xerox, right? And seeing, I think this lore is Jobs saw three things. I think the graphical user interface, the mouse, and Ethernet, right? And
Yeah,
he was so blown away by the GUI, he didn't even notice Ethernet, right, or something like that. I
right.
think is the story. But anyway, but it's also stories that there were a couple engineers pilfered from Xerox to come to Apple, and you were one of those people, right?
Yeah, well, I just got in under the wire. They had a cease and desist, I guess you call it, where it was not legal to hire somebody from Xerox, but I just got in under the wire.
Mhm. Yeah, and to this day, like California is very liberal on non-compete. Like they don't they believe innovation. They don't enforce the non-competes. I guess I'm no expert there, but so tell me, like you gave a talk at Apple, is that right on printing?
Yeah, the reason I went to Apple is I wanted in our research lab in New York, we were using Ethernet, and it was back in the days the way you added a new computer to the network is you literally drove a spike into the cable, and and that creates all kinds of ringing problems on the network. And so my job was to go figure out how to solve that. And I thought, well, let's go get an Apple II and hook it up to our network, and it'll just sit there pinging back and forth at low bandwidth, but finding out if there's an issue with the network caused by these spikes. And there's a way to correct for that, having to do with the Hamming codes and stuff. And and my idea was I wanted to use an Apple II, but I couldn't get the information I needed. So I called a friend of mine, Larry Tesler, who was at Park. And it turned out that he was in the process of leaving, or excuse me, going to Apple. And the I said, well, what do I need to do in order to understand how this system works? He said, well, why don't you come out? What are you doing? And I said, printing, because I was doing printing at Xerox. And he said, well, we're interested in that. And I said, well, okay, that's fine. I'll give you a talk on printing. And I know that you're interested in laser printers, but I want to convince you not to try to do it. It's computationally intensive because mainly once a laser printer starts to print a page, it can't stop. It's doing basically re-imaging all strips of the page as fast as it can, and to keep up with the hardware to be able to keep up with the that you can't stop now page printing. So I said, well, let me give you a talk on this and why I shouldn't do it. And so I was in the middle. I gave 3 talks. The first one was basically an overview of what printing is really like down deep inside. And I showed that it was not computationally possible with any of the desktops of the time. And there was this back in the room, they said, well, wait a minute, what if you do X? And they kept saying, we can do it, basically. And I said, okay, well, convince me. And they offered me a job at the end of the talk. And I went out and said, oh, this is great. I like it here. It might be fun. But then I found out what housing prices were like. And I just broke down in tears, literally, because I said, we can't afford to live here. And then they said, oh, well, you don't know about creative financing. Said, what? Creative financing? You mean like you design it differently? No. Go talk to the people who were running Apple at the time. And long story short, I ended up there. I think it was 4 months later. Oof.
Did you go right into the Lisa team at that
Yeah,
time? Or?
I was working on the Lisa team. I brought 2 of the people from Xerox New York with me, Steve Capps and Bayless Holt. Bayless was an expert at hardware, and actually he built a laser printer in our lab in Lisa well before Adobe. I mean, there's a funny story about Adobe. The reason PostScript was so interesting is that it became usable by anybody. I guess you call it open source nowadays, because they had given a talk where all of the PostScript internals were discussed at a SIGGRAPH. Well, the day after the SIGGRAPH, both John and Chuck left Park to start their own business, Adobe, because now the work that they had done was public domain. And now let me see, how did I get here? We're basically
Lisa team and
yeah, okay. We were building our own laser printer and looking into how to use Adobe once it got online because we knew all the people involved. And Steve Bayless and I had the had a multiple printer architecture for Lisa at that time, but I don't know what's next. Oh, well, at that point, we also had the Pirates. You know, I don't know if you know about, there was a period where the Lisa team and the Mac team were at odds with one another, I guess is the nice way to say it. And they had this pirate flag, and there was even one at one point, as the Lisa proved to sort of not fail so much, but not being a commercial success. They there was this day where they put up a pirate flag on the Mac building and wouldn't let anybody else come in and out. And it was supposed to be, you know, we're better than you and bye-bye because you're not going to last for long. And indeed, Jobs killed the Lisa project at about that time.
and then you transitioned over to the Mac team, or how did that transition
Well,
happen?
before this occurred, I went over to look at what was going on because Steve Capps at that time had moved off into Mac full time. And so it was just Bayless and I, and a couple of other guys at that point. But let's see. So I went over and talked to Bud Tribble, who was the manager of the Mac team, and said, well, what are you doing for printing? And he said, well, we're just going to do screen dumps. I said, no, you got to be kidding. And he said, well,
Wow.
we can't do any other way. And I said, well, I bet I can do better than that. Now,
Wow.
and
And
so
just to be clear, the Mac screen at the time was like 530 by 3 something, right?
I was very little, not a
It
lot
was
of
very
bits.
like I mean, that was one of the negative selling points was compared to the IBM was the
Right.
size of the screen. So imagine what the Mac would have been with a screen. But keep going. Yeah.
Well, but at any rate, I ended up with my office over in the Mac building at the point. I was still doing some Lisa stuff. We built our own daisy wheel, for example, to do letter quality stuff, with which had 3 little dots, so we could print the fish. But at any rate, and so I was basically changed to the Mac team at that point because Jobs was always interested in printing, even when when we did the CETO work. And I sent you that lovely picture that Steve Capps put together, image that is of just what daisy printing, or excuse me, raster printing is like. Mainly because the CETO printer team came over and Jobs said, well, see if you can get them to take all of the stuff out other than just what you need to do raster printing because it'll be cheaper. And I did that, and they came back with their price, and it was like a third more expensive than getting it. And they said, you know, it's just so many people are buying the CETO printer within Apple at the time. It was being used on the Apple II and others, et cetera. But the important thing is we couldn't convince them that we were really going to do raster printing and only that. And Steve's lovely image made when we brought it in and showed it to them. Just there were like 6 engineers from CETO, and one of them jumped up and started talking to all their friends and pointing at the picture and saying, "Whoa!" And we were doing half scan, which is I think how many bits did we have? I think we had about 12 bits in height. they would scan over once, and then you'd move it right in between the bits you get and come back, and then you get twice the resolution. And actually 4 times, because we could slow the thing down to go over slowly.
Oh wow, it meant varying the speed too.
Yeah, yeah. Is so we did some pretty hot stuff there, and but when they discovered it, they said, This changes everything." And they were talking about we were having trouble with registering that halfway in between the prior scans, so you get so much higher quality. Um, and they said, "Well, we can actually make it better." And of course, then they went off and came back to Steve and said, "Steve, there's good news and bad news. One is they will give you what you want, a printer with no letter printing inside, but it'll cost you a third more or something of that nature." And he said, "Oh,
And this was the image writer,
yeah,
right? First, the
yeah,
impact, still impact dot matrix, and then the laser printer shipped a little bit a few years later. Is that right, or a year
yeah."
later?
We once we did that, well, Steve was always interested in. He was a funny guy, really very broad interests, and he got very, very interested in different printing technologies. It's almost like um, somebody's in the patent office with their wonderful new thing, and and we would talk to these people, and had like Sputter Jet was one of them that I loved. It was sort of like an jet, but it was so dense. You could actually feel on the page that it was like in being embossed, or the reverse of that. But at any rate, um, we that where I remember most of us getting involved with Adobe is that was at a birthday party at his place, and we all went out, and Steve was in the pool, and he said, "Well, what is this Adobe printer business?" And I said, "Well, one, we've already built one. You could come look at it in the lab. But two, some of the things that are going on because of PostScript were really fascinating, like infinite fonts. Once you describe the font mathematically, and then use the curve technology and the bicubic splines and the joins with um, the tangents remaining the same on both sides and all that kind of stuff. You could get these gorgeous fonts and get them by the ton. And usually you could take just one version of it and have it scaled between, uh, several different sizes. And he wanted to know how that worked. And so I gave him a little talk on bicubic splines, and he got the gist of what it was all about. And I said, but also the other thing is it's a language. And he said, "Well, what do you mean by
The
that?"
PostScript was the language. Yeah.
Yeah,
Hmm.
and
Hmm.
that you actually tell the printer what you want to do. You don't make barriers. You don't say, "Okay, here's this rigid way that you use the printer." Instead, here's a language, and anything you can do within the language, you can do on the printer. And Steve got that right away, faster than any of the engineers, because he understood it from sort of the commercial standpoint, the business standpoint, that, oh, we have something that can span multiple um, domains. We have, different companies is one way to look at it. They all have different printing needs, and this thing can span them all, or at least a huge amount of them.
Yeah.
And he
I'll
got
say,
that.
I did, yeah, later, like in 92, I was watching a Jobs talk. I think I have it here. Let me share my screen. Well, first of all, here's in 84, Rolling Stone featured your team here, and you can see the crew here. That was but this was one of the main spreads here, and here's here's the group here. There's some nice bits here, and here you are up on the pyramid and the with the rest. And so
I like the part
so
where the pyramid crashed. Then we had another picture.
oh, right after that, yeah.
Yeah,
You saved the baby though. That's
we
good.
did. We did.
Um, there was a period here. I was just watching. Let's see.
Oh, that picture's cropped. There is one where Jobs came in. He wanted to see what was going on, and he was off to the right there a bit.
Mhm.
Oh, it's probably got it in there, yeah.
Okay. Um, so oh, here it is, and people can watch this. It's pretty dense, but if you just Google Steve Jobs, MIT, 1992, Sloan School, and there was one point in here where he said, when they shipped the Mac, they didn't know that desktop publishing was going to be so big. But after, they started maybe the next year, they started to see the uptake and they completely pivoted their marketing. And that was transformative. But I'm going to point out though that during your talk, you mentioned at the end of your answer about letter quality printing that you wanted to go after the typesetters and make apps for the prepress industry, right? And I did find it interesting when it came back to Steve, he was still kind of thinking about the letterpress or the letter quality printing, and probably wasn't completely tuned into your answer because I'm going to give you credit that you kind of saw that need even when the Mac was released, and people can watch that 92 talk where Jobs said he didn't see it. So one is just a little kudos to you for seeing, you said you wanted to go after color, you wanted to go after resolution, and you wanted to go after typesetting. And as I mentioned before too, um, I was in high school running a typesetter in the journalism department with the advisor Chuck Knowles, and we had a nice dark room and really learned a lot about graphics and the actual getting it to material, learning about halftoning. That came a little bit later in the 90s. And we were hooking up Mac 2s to the photo typesetter. And back in those days for people and I keep saying like things like letterpress instead of letter quality. That was even earlier days of printing technology and lead print. But photo typesetters, just for people that uh, don't know, was a little disc that would spin around, and you'd have photo paper, and depending on how far the disc was away, and it basically had cutouts of your letters, and the further away was the bigger font. So you'd basically expose this image, and that was your typesetting. Instead of using lead type and it was a photo process, and then making film to go to press. And this was all, I think what you were talking about, Owen, is like this is a very manual, analog process, and what if we can make it digital? And that was huge. And I'll just tell you, when got out of, let's see, in undergrad, I was kind of playing with AutoCAD and Lisp, and that was a place where we had, I loved to be able to make a 3D model as a language. Like AutoCAD was kind of like PostScript. You could script it, right? And then express things. And then in after undergrad, we moved to Florida, and we were a Macintosh VAR, Apple VAR,
Yeah,
value-added reseller, focused on helping commercial printers use desktop publishing. Like, how do you go from what used to be very expensive Hell scanners, $50,000 and SciTech to do your digital manipulations to doing it on a Mac? And early days of Photoshop and Quark Express. I was kind of like Quark over PageMaker, but how do you do your page layout? And instead of what used to be manually stripping, which was taking your film and Exactos and paste up and getting everything together. Well, that's what the page layout programs did. And again, I didn't know you, right? So one, I didn't know you in '83 when you're doing, or '84 when you're doing this, and then that was my first. I really like the graphics side. I grew up in the TRS-80 Apple II era, but it the graphics really appealed to me. And then later the multimedia, like Macromedia Director, and then the internet in '94, or the web. Obviously, the internet was before that, but the web kind of breaking out. And so I just want to kind of start moving us into the late 80s, where you left Apple, right? And
Yeah,
we kind of build up into this
84 or
era.
5. Yeah.
Yeah. And then you popped over to Sun.
Yeah. It was
That's
a funny story. Wayne Rosig was my boss at Apple, and we were after the Mac was released. A lot of us started. Well, one, the carpetbaggers, so to speak, arrived. Apple was sort of taken over by.
now I just want to, because I've heard you use that phrase before, and I also see that. I saw that at Adobe, I saw it at Macromedia, I saw it at Carpetbaggers is basically where the sales guy take over for the engineers in running the company. Is that a fair?
Yeah, that's a good way. I mean, they basically said, "Oh, here's a good thing. Let's go make it ours."
Hmm.
Um, and and that really flushed. Most of the Mac team left within a year of each other, and I stayed a little bit longer because I had a sort of a researchy job um, at Apple, and I was looking with Steve. Let me see, Alan Kay, myself, and um, two other people came up with the idea of the Big Mac, as we called it, and that the idea
The
was,
512 or yeah.
well, it would, first of all, it would use Unix. Second of
Oh
all,
wow.
it uses PostScript for imaging, and third, it would have a real networking because we really hadn't had real networking at the time.
Oh, oh, I see. So this is not that, Apple had a Big Mac, which was 512 memory, but you're talking something much more
A new
revolutionary.
a
Yeah.
research
Which
project that
became,
was that would also be a lead into a product. And the
mhm.
so I go to talk to Wayne about this, and he says, "All right, I've got everything set up. You're going to have a lab. You're going to go build this device, but I'm leaving to go to Sun Microsystems." And I said, and I had just interviewed them 2 days before, and I said, "But literally, my words were, but Wayne, that's my line." And so I went over and I got there. I was the one, you would have a card, and they would have number and they would do it by the number. And so I was, 98 and he was 99. It was fun. But yeah, it's kind of,
So this what you went into in the R&D lab, or what'd you do at in the Sun Labs,
um,
or?
they I was going to try to convince them to do what we had done on the Mac, but do it for their products, which were uh, more oriented about fairly heavy duty desktop um, workstations, I guess is the phrase they used, rather than just computers. And they already have a very good system built on Linux or Unix, I should say, and using a good network and all of that. But they didn't have the user interface that Mac had, and they were starting to work on that. So I helped. That's where I was working for a couple of years, and then you move around a lot in a place like Sun.
Yeah. What was news at that time?
Well,
PostScript news, or?
um, there were a couple of outfits that were working on, since the network was getting pretty solidified in terms of what it was, and they were standard across different organizations and companies, which was really quite a breakthrough. Um, the idea came up of where does the network place the desktop in terms of the user interface and that kind of thing. And the interesting idea came up as well. You have the workstation do a fair amount of the work, but also have a bunch of the work being able to be done on another machine. And news was Sun's jump into this area, network extensible Windows system, and NEWS. And James Gosling was working on it, and I got to be the second person involved. And he was doing the the system level programming, and I was taking the result of it and turning it into a user interface. And so we built TNT, the news toolkit, which was a really nice and very flexible and adaptable user interface for it, sliders and buttons and all that kind of stuff. And it became really almost a cult phenomenon. Once somebody got into it, it was hard to drag them away. But that was sort of my next step within Sun, was to go from building the software, user interface software, to working with James on news.
And Sun was famous later for the phrase, the network is the computer, right?
That's
So
right.
in some ways you were early days on that,
Well, the
looking at
thing that was
ways of, yep, go ahead.
cool is that James figured out that throwing actual code around is much better than throwing. I mean, you could do network printing with the networks that we had that were quite fast. You could literally do all of the computation to create the bits on your workstation, and then just literally spew those to the printer, and you can do it in real time even. But that wasn't it was hard on the network and how stuff like that. And so sending programs around, not unlike today with the browser where you're sending programs around, but way back then to the thing that was interesting about news compared to the other systems is that you were not limited, since your program it's a language. You can do things that the designers would never have thought of.
Yeah, I'm just bringing up
Yes,
this
that's it. The little D.
little Wikipedia on news here. Some of the early interfaces here. Has a kind of a HyperCard feel too, doesn't it? Okay.
There we
Oh,
go.
you're back. Was that speaking of the network?
Yes.
uh, I was briefly showing you the news Wikipedia, but uh, we're good. Um, well, so then, that was a huge time in the 90s, right? With the web breaking out. Sun was one of the go-to web server file servers on the network,
Right.
right?
Yeah.
And so you rode that, and I think another thing with Gosling, Java was a big deal. And
Yep.
you want to talk about the Java car?
Oh, yeah. Well, Java was a very interesting language that James came up with. Um, he's did a million different programmatic sort of things, like oh dear, what's the Lisp for your desktop that people had? But at any rate, um, the I had a small group called the Skunk Works, where our job was to go experiment with new technologies, explore new technologies, and find out what impact they have on both Sun's customers and on Sun, the company itself. And so we got involved with early radio-based networking. There was an outfit putting radios up on all of the light poles to try to build a sort of the equivalent of Wi-Fi, but well before the time. But one of the things we came up with is um, building a car, by I mean building a car is outfitting a car so that it would be very hyper modern. And this is in the late 90s, and so we were doing things like you could speak to the car, and we discovered that it's very hard to speak to a car because it's very noisy. And so you have to figure out, well, how do you solve that problem? And it turns out the answer is you get instead of a simple microphone receiver pair, you get these bar mics that are a strip, if you will, of smaller devices. And we came up with an architecture that had two networks: the car network itself within the car, so that you couldn't put the brakes on or anything like that. As a matter of fact, we knew how to do that, but it was against the law to do so. So we didn't continue that. But with the idea of being able to talk to the different parts of the car was useful. But the other thing is we built a network outside of the car, literally car to car networking and car to land networking, for lack of a better word. And so we built this Java car, and Scott McNeely, who was the head of Sun, was from Detroit and was very interested in what Detroit would do with this kind of thing. And so this Java car ended up being, we had the skunk works tend to have roughly 10 or so investigations going on at a time. And this turned out to be one that was interesting enough for Scott that we actually turned it into sort of a product, in the sense that he would go to these shows and he would show the things for example, to start the car. I mean, my current car, you come up to it and it just opens and closes. It knows how to do that. But in those days, what you had is what they called a Java ring. It was a ring that was pretty big. And it actually had a working version of Java within it. And you could use this to start the car and also to give, like if you're getting a car repaired, the people at the repair shop would be able to use another ring that you gave them, and it would limit how far they could drive, for example. And there's peculiar sorts of things, but Detroit really cared a lot about that. It was sort of like our relationship with between the printing work and Jobs was between the Java car and McNeely. He would go around and present all this stuff to people in Detroit. And I kept saying, why? We're not doing this because we want to build a new car. We're doing it because it's an interesting environment to try new technologies that our customers and we want. But at any rate, it was fun.
It's getting code onto the network, right? And
Exactly.
then talk to me a little bit about then what epsilon was, because I think
Um,
that's related in some ways. Yeah.
sure. I ended up moving from the Skunk Works into Sun Labs, and there teamed up with Randy Smith, who was a park researcher, and we were just told to go find a project to do and do it. And we said, what would be an interesting thing to do? And one way or another, we came down to the idea, what is the smallest piece of computing you can create that's useful? And because of the epsilon delta definition of what a continuity is or a limit is, we looked at really tiny pieces of computing. We were using Band-Aid size computing platforms and seeing how we could make them work together to become a bigger computer, if you will. They think of it, each one of our epsilonic devices. There we go. Each one of our epsilonic devices wasn't particularly good by itself, but as a swarm, they do very well. And that's kind of where what Epsilon was all about. And after we had messed around with it for a while, it was popular enough that it became more grown up, if you will, and was halfway into product line by the time I left.
So really small devices that are interacting and having emergent behavior sounds
Exactly.
somewhat familiar.
Yeah.
So we're kind of in the late 90s. What brought you to Santa Fe?
Well, I had found out the big companies have this sort of treasure trove, if you know how to use it, of getting interns. So we always had a huge number of interns on our projects, from mainly from Stanford, but Berkeley as well. And um, but it turns out that Sun was engaged with the Santa Fe Institute, and there's a summer school, and I found out about it, and somebody gave me a paper on it. And I said, "Boy, that sounds cool." Uh, it's kind of nice,
Mm.
and so I took pretty seriously the idea of going out and talking to the people at SFI, and we found out that the summer school was open to us. They had some, because some paid to be part of the SFI business network. Um, I could go and go to the summer school, and terrified, I did so. And that's when we met.
And I think that's where we met, right?
Yeah.
Mhm.
Yeah.
Um, and some of the work you did, I remember search on power law networks. What was
Yeah.
it?
Well, that was probably driven to extremes, but basically, we just wanted to, we were looking at how networks self-organize. And uh, so it was actually along that direction. Um, uh, how do you deal with the fact that as these networks mature, the number of connections they have and all that sort of thing is unbounded. And there it is. Yeah, golly, I didn't know that was out there, to tell the truth.
It's on backspaces.net, which is for
Oh, that's a wonderful place. Yeah, you should go there.
so this is you're really getting into the science of networks and the mathematics of them, right?
Well,
And
the shapes that they take. One of the
Mhm.
things that was surprising is that they morph into lobes and that kind of thing. And that can make the searching very slow because you have to go a long way down a lobe. And you have to, if you were searching for uh, a, some particular values of some sort, uh, properties that are on the network, you'd have to do a complete search and it'd be very expensive. And so the question is, was there a way, can you manage the complexity of the network and the fact that it's not just, a very simple shape, if you will, when you connect all of the dots, they can morph into very strange shapes.
so so I was at BIOS group at the time, and I think we were both attending the Santa Fe Institute Summer School as BizNet members, in addition to uh, the PhD students. And the dot-com crash happened in 2002, and I was maybe going to go to Boston with Ike, but I stayed in Santa Fe, right? And you moved to Santa Fe, and we started working together. And I'll just say, we got an office together, and I'll just say for 5 or 6 years working closely with you, it was only after 5 or 6 years that I would realize you were on the early Macintosh team, which I
Yeah,
just as a shout out to other people, it was like that's one definition of no ego as far as like so I would have told someone right away, hey, I'm Stephen Guerra and I work on the Mac team, right? But it took me 5 years or 6 years to even to learn about that history of
Well, the
you.
problem is I kept working at such neat stuff. It was more interesting.
So so I do want to kind of know the evolution of us working together. You know, we have the we started the Santa Fe complex and the Friday morning group that's been going for 25 years or so, meeting up in Santa Fe, and you know, just a bunch of wonderful retired academics, Los Alamos fellows, technologists, artists in Santa Fe. And we started up the Santa Fe complex in 2009. And I think that's where you met Ed Angel. So I'm going to move to graphics basically and agent script. And I guess the common thread I'm also going to is before this call I mentioned to Owen, as I look at his career, he's always been at the edge in computing. And I mean that in two ways. One is just innovating and changing the face of computing, um, but also programming the edge devices, Epsilon on the edge, the printer as computation. You know, you don't have a big computer and a dumb printer. No, the printer is just as smart as the computer, and the code is moving, and code is running everywhere. You're moving code around, and having all and really focusing on the edge and in the Santa Fe kind of way too. It's a decentralized, distributed, but through the collective behavior, it's emergent and it's greater than the sum of the parts, right? So
Yep.
with that, we're going to talk with Ed Angel, one of the leader, kind of at SIGGRAPH, which is many people can Google SIGGRAPH if you haven't heard. It's the special interest groups of the ACM on graphics, the special interest group. And Ed is a longtime OpenGL, which is a form of using parallel computing on our computers in gaming and you know your GPU cards, which now in AI is so important, and this parallel processing. So one, let's just talk about Ed and WebGL. Well, first of all, not WebGL because Ed was in OpenGL, and then where you're going with AgentScript and what you think the connections are and where the opportunities are going forward. Yeah, so that's a big question, but I'll let you take it in
Um,
parts. Yeah.
we at the complex, one of the things that we wanted to do is to use it as a way for us to learn as a team because um, so each of us would know do a deep dive into one area and then present it uh, to the team and to the rest of the people at the complex. And Ed volunteered to go uh, basically to teach his he has a book that's quite famous and used in many of the universities. And we used it for the basis of our of 6 to 8 of us taking the course with Ed at the complex. And the thing that was interesting from my standpoint is that uh, we we had to figure out how to oh, there you are. We had to figure out how to do the work for the class. There we go. And so when we started it, I got I thought, well, one of the possibilities to do this with the browser, just do all of this stuff using browser-based stuff. And the first homework I handed in was a web page, and I gave the URL to Ed, and he said, "Well, that's nice, but where's your homework?" And I said, "But Ed, click the links." And boom, all of a sudden, he had this aha experience about what? You're using JavaScript inside the browser to do my class? And I said, sure, that seems like a good idea, isn't it? And uh, he would he was thunderstruck, I guess is the right way to say it. And he was working on the next edition of his book. And just that experience, the fact that, for example, he knew that all of the people who used his book in their classes spent an enormous amount of time to try to get it set up on their desktop, get it all running with the various Python and JavaScript and all of that stuff. And it was enormous difficulty. So envisioned that he could write the next version of his book where people just click on a link and they're able to see the results of what's going on in the book, but not have any of this setup work, just mind-bogglingly difficult. So off he goes. And the next edition of the book, I think you and I are both mentioned. He mentioned that, well, there's been quite a change in the way we're doing things, and we're using the web. We're using URL. You can somebody send your homework in with URL, if you will, and he's been keen on that ever since.
So being able to do the graphics in the browser, and then I'm going to combine that with just another idea here. Starting in about 2002, you were exploring one of our favorite tools, and a shout out to Early Lewinski and his team at
Oh, yes.
Turn is NetLogo, right?
Yeah.
So what are we looking at here?
Well, this is the ants program where ants use pheromones to guide themselves to and from food sources in the home, and this is a nice example of that written in that logo.
Yeah, and for I think for both of us, the language is very approachable, something you can teach sixth grade to 12th graders. Now this is a desktop application. It does run in the browser, but in the early days, where you've I think pushed it more for performance. And I just want to introduce AgentScript here, your work that you've been on for the last 6 years or so, would you say? Or
God, who knows? A long time.
yeah. So yeah, what are we looking at here?
So NetLogo's fundamental architecture is beautifully simple. It has the notion of three critters that patches, turtles, and lynx. And what's you can have them all do different things. You can have one, like you can have turtles take on different roles and patches, etc. It's a very live. It's an amazing from such a simple definition of or architecture. The amount of things you can do in it is just mind blowing. And so this was back many years ago. We decided, well, can we do a version of this that would be nice to do in the browser? There again, with Ed, our experience with Ed, it was such a fascinating thing. And so that's what I've been working on recently, and we're pretty much there. I'm trying to do the last bit of the documentation and get it ready for prime time, if you will.
And so now you have this whole application authoring environment. To me, again, on this career through line, you're making it so people can make small programs that can run anywhere. Is that
That's right. Yeah.
and it's an authoring and the graphics and the visualization is embedded in this too. So here
Right.
I'm just looking at a shallow water equations here where you have simple cells that are just looking at their neighbors and responding. I mean, just that's the single line of code that they're just looking at the height of their neighbors and adjusting based on that. But from that, you get this interesting wave mechanics again. So a sixth grader could actually program quantum field theory. And so I don't think it's realized yet the impact in the same way that Jobs didn't necessarily see what you're I think this is going to be just as transformative, especially when these become network aware, on the network, the news, but with agents here, right? And I see all your examples here, like bringing in 3D and GIS. If we went into other kind of things here, we can go into uh, you know, standard geo modeling, putting rainstorms. Here's the code, but we can actually look at water moving on real landscape. So it's not just dots on screens. So here's Santa Fe, and just bringing in the elevation automatically, and you're figuring out where the water is going to go for flooding or something like that. So I just wanted to give major kudos and thanks, and just as a your colleague for 23 years, just mad respect and um of your career. And I just think the through line's also just kind of interesting for me personally, that when the Mac was released, I was a typesetter, and then
Yeah.
I was a VAR in doing uh, helping people do desktop printing from your work, and then to meet you in 2000 and being able to work together. It's the greatest privilege, Owen.
Oh,
And
sweet. Thank you.
so, and thank you for doing this interview. And I think it's very important for people to know the contribution, in my opinion, that you made to computing. People don't even, I think they just take it for granted. I mean, just like, I'm just reaching over here. You know, here's our brochure for SimTable, our company, right? That was made possible because of you. If we all had Lenter quality printing, big deal. You made the vector to raster, being able to do the mathematical curves and get it and make the printer smart. And I'll just say that, well, I think the next thing that we're collectively working on is how do you take the lasers and make the room interactive with light?
I think
That's the
that's
next
brilliant.
the
Yeah.
printer for the room as we interact in the light. Because at the end of the day, the printer is subtractive. We have light and we're subtracting with the printer, but now we have full control. In fact, in my room here, you can't really see as I projecting up on the wall. Now we have projectors and ants on the wall, right?
Yeah.
Overlaying that. So it's just yeah, thank you for being on this journey with me, Owen. And I just wanted to make sure other people knew about your history and what you've contributed and you've changed the world. And
Well,
you're one of the
thank
crazy
you.
ones. You're somewhere on the spectrum. You're one of the crazy ones, but you've made it a big impact. So thank you for that.
Ciao, ciao.